Good afternoon, viewers at home. I am Banjo Olaleko Peter, a graduate of Obafemi Awolowo University, Ile-Ife. BSc Mathematics, MSc Mathematics in VIEW, Bachelor of Medicine, Bachelor of Surgery in VIEW, Ladoke Akintola University of Technology, Ogbomoso. Today we want to quickly check a brief review of the relationship between equilibrium constant in terms of prayer and equilibrium constant in terms of concentration. We want to quickly check relationship between Kp and Kc. A relationship between Kp and Kc. Now, Kp means equilibrium constant in terms of prayer. Kc means equilibrium constant in terms of concentration. So let us try and consider the equilibrium reaction. Let's say you have AA plus BB, reversibility sign, CC plus DD. We want to put into consideration this equilibrium reaction. We know that from ideal gas equation, we know that what? PV is equals to nRT. That's PV equals to nRT. Now, if I divide both sides by volume, say divide both sides by V, we are going to have P left here. We are going to have nRT divided by V. That's P equals to nRT divided by V. So I can simplify this to give me something like N over V multiplied by RT. Knowing fully well that N over V stands for concentration C. It means that we can replace that and have P is equals to CRT. That is P equals to CRT. Now, for the equilibrium reaction above, if I want to write Kp, equilibrium constant in terms of pressure, we have that Kp is equals to partial pressure of C to power of C dot partial pressure of D to power of D divided by partial pressure of A to power of A dot partial pressure of B to power of B. Now, knowing fully well that our P equals to CRT, where C stands for concentration, we can easily replace it here so that we can have something like our Kp is equals to, instead of this P, we have CRT to power of C dot CRT to power of D divided by CRT to power of A, then CRT to power of B. Now, in that regard, CRT, we have a subscript of D, subscript of A, subscript of B. Now, by the time I simplify this, we are going to have like Kp is equals to C of C RT raised to power of C dot C of D. This will be in capital letter. C of D RT to power of D divided by C of A RT to power of A dot C of B RT to power of B. In that case, I can bring them together. I can have like Kp is equals to Cc dot Cd. Then we have RT raised to power C plus D by law of indices divided by C of A dot C of B, then RT to power of A plus B. So in that case, this concentration of C, concentration of D, concentration of A, concentration of B, I can write it as Kp is equals to concentration of C raised to power of C, concentration of D raised to power of D divided by concentration of concentration of A to power of A, concentration of B to power of B. Like that. Concentration of A to power of A, concentration of B to power of B, concentration of C to power of C, concentration of D to power of D. Dot. We now have RT raised to power what? C plus D in bracket minus A plus B. So the whole of this here is Kc. So we can have Kp is equal to Kc like that. Then RT raised to power C plus D. That's C plus D. That's change in number of moles. A plus B, change in number of moles. So C plus D minus A plus B, it is representing change in N. So when our change in N equals to 0, we have Kp is equal to Kc into RT raised to power 0. But anything raised to power 0 is 1. So we can have Kp is equal to Kc. So the only condition for us to have Kp equals to Kc is when the change in number of mole is 0. But when the change in number of mole is not 0, our Kp will not be equal to Kc. So relationship between Kp and Kc will just be Kp equals to Kc RT raised to power change in N. Full stop. Good afternoon.